Medical news from medRxiv. Exploratory dried blood spot metabolomics identifies pathway-level convergence with ME/CFS biology in a self-reported PEM-like fatigue phenotype. A large community-based metabolomic investigation has shown that dried blood spot (DBS) profiling can capture biochemical signatures that echo the metabolic disturbances previously reported in myalgic encephalomyelitis/chronic fatigue syndrome (ME/CFS), especially in individuals who self-report post-exertional malaise (PEM) like fatigue. By demonstrating pathway-level convergence across multiple analytical platforms, the work suggests that minimally invasive DBS sampling may become a practical tool for probing the complex biology of fatigue syndromes in real-world settings. ME/CFS affects an estimated 0.20.4% of the adult population and is characterized by profound, persistent fatigue that is often worsened by exertion, PEM. Prior plasma and serum metabolomics have repeatedly highlighted hypometabolic states, altered lipid handling, mitochondrial dysfunction, redox imbalance, and dysregulated tryptophan-kynurenine metabolism. However, most earlier studies were limited by modest sample sizes, heterogeneous case definitions, and reliance on serum or plasma, which are less amenable to large-scale community screening. This knowledge gap motivated a study that leveraged DBS, an inexpensive, stable, and male-compatible matrix, to test whether the same metabolic pathways could be detected at scale, across a spectrum of questionnaire-derived fatigue phenotypes, and using orthogonal liquid chromatography, LC, gradients within the same individuals. The investigators recruited 1,784 adults from a community cohort and collected finger-pricked DBS cards that were later extracted for metabolomic analysis. Reverse-phase liquid chromatography coupled to high-resolution mass spectrometry, LCMS, was performed using two complementary gradient lengths, 5 minutes and 15 minutes, to capture both rapid and more resolved chromatographic separations. 6 fatigue-related endpoints were defined from self-report questionnaires, including a pragmatic PEM-like phenotype, the primary phase 1 endpoint, a DSQ-derived PEM construct, clinical status categories, temporal fatigue state, comorbid fatigue, and chronic fatigue. After excluding participants with major metabolic comorbidities, the primary endpoint comprised 226 cases and 914 controls. A biology-first panel of 22 metabolites, curated from the ME/CFS literature, was interrogated, each represented by 4 participant-level descriptors, e.g., intensity, ratio, z-score. To broaden discovery, the team also performed a targeted M/Z search for additional literature candidates, a hypothesis-free univariate screen across 4,553 consensus features from the 5-minute runs and 5,625 from the 15-minute runs, and calculated pairwise z-difference ratios. Ridge-penalized logistic regression models were trained for each endpoint, and performance was assessed via 5-fold out-of-fold area under the Receiver Operating Characteristic Curve, AUC, with bootstrap resampling to gauge stability. Across the primary PEM-like phenotype, the biology-first panel reproduced several of the hallmark metabolic alterations described in prior ME/CFS work, notably reduced levels of long-chain acylcarnitines, perturbed phospholipid species, and shifts in kynurenine pathway intermediates. Although exact AUC values were not disclosed, the authors reported that the Ridge classifiers achieved modest discrimination, with bootstrap-derived stability indicating that the signal was reproducible across the 2 LC gradients. The hypothesis-free screen identified additional features that clustered within the same lipid and mitochondrial pathways, reinforcing the notion of pathway-level convergence rather than isolated metabolite hits. Pairwise z-difference ratios further highlighted coordinated dysregulation of redox-related metabolites, suggesting a systemic oxidative stress component. Subgroup analyses revealed that the metabolic signatures were most pronounced in participants who reported acute PEM after exertion, compared with. Thank you for watching. For the full article visit MedMind AI at medmind.pro. Like and subscribe for more evidence-based medical content.